next guest is Sean Darcy, who's the Director of Aerospace and Defense for a company called Analog Devices. And Sean, you were telling me before we got going here that you may be the biggest, least known company in the room.
Correct. Here
at AEA. So give us some of the history of your company to start, and then we'll talk about some of the things that you do.
So Analog Devices is the leader, or one of the leaders, in taking our analog world, converting it to digital, and then taking it back to the analog space. So a lot of our products are in the radio frequency, or RF, part of the spectrum. We also do things like MEMS, which are micro electromechanical systems. We make gyroscopes for ADAHRs. We make a lot of things that go in software-defined radio cores. So we have things called transceivers, and they make a lot of the things that support it, like precision motor control, precision sensors, and we recently just acquired a rather large semiconductor company, Linear Technologies, that gives us a large power management portfolio as well.
So when you say you take things out of the analog realm, convert it to digital and back, you're talking about things like is happening right now with us. My voice is analog.
Correct.
It's being picked up by a microphone. It's being converted to digital in a box that's over there where Nathan is sitting. And then it's back to analog by the time it goes over a speaker and into somebody's ears, or they see it. That's
totally correct, yes. And so we make a lot of the things that are called ADCs, analog to digital converters, and DACs, which are the reverse, digital analog converters. The challenge in the market has become ever faster, ever more accurate. They can sample quicker, and they put more bits into the digital backplane.
So what's your niche in the aviation market?
So a lot of the stuff we do is we enable most of our customers are the big aviation companies. So we enable really a lot of the electronic design for probably the 30 or 40 largest aerospace and defense customers worldwide. And so if you look at what we do, we help provide solutions to those customers. And a good question that you asked is the niche we provide that in, for example, is MEMS devices, which are very high precision gyroscopes, high precision inertials, and then high precision MEMS-based magnetometers that go into ADAHRs from everything from general aviation all the way up to ATR, air transport and regional type aircraft. A lot of people don't know, we provide the artifacts that allow us to be certified as a DO-178, DO-254 device. We're DAL A and DAL B in those. We also do a lot of stuff which becomes the enabling to software-defined radios. So a lot of the stuff is military type technology or frequency hopping technology that, because of the way it's designed, makes a very, very good base platform for smaller, more compact, far more high precision software-defined radios. So an example is, as we become more accurate in splitting the spectrum, now instead of having a VOR receiver, nav radio, a COM radio, a GPS receiver, a transponder, we can actually start putting this as one signal chain. So you have a lot of commonality that now you don't have to design all these solutions. Now to the end user or pilot, they're going to look like different solutions, but the core radio itself becomes the same radio. Drives down cost, drives down time to market, also makes it much easier to deal with reliability or obsolescence management in the future.
When you look at the way that the technology that is going into airplane cockpits is evolving, how do you see kind of the integration of the digital realm into that? What's going on in that technology that is important for your company?
So there's a lot of things we do. It's interesting. We have probably the broadest portfolio of analog side of the signal chain components in the industry.
For instance?
And so if you looked at the ability to do an entire signal chain from basically the receiver and the antenna, the amplifier, all the way back to the radio, convert it to a microphone and take it all the way back, one of the few companies that have all the components that do that. So a lot of things we do in the industry too that's important to us, and where we actually try to help our partners drive forward, is things like the Wake initiative, which is the wireless, a lot of wireless sensors in an aircraft. We have an ability to package those and spin custom dies in a way that makes the integration so small and the power so little that you can actually take and put into an aircraft a low power transceiver core with a low power sensor, some minimum processing, and you have a sensor that sits on a battery without any power or any wires to it for up to 10 years. So now you're removing a lot of weight from the aircraft, et cetera. The other thing we do a lot of is in SATCOM. So the phased array stuff that we do on the military side or the base station side, that's the SATCOM antennas that you take the big bulge off the back of the big 737, replace it with a flat plate.
Okay.
Far more effective. Your maintenance interval is 2 orders of magnitude less than it is mechanically scanned. So that's a lot of the stuff we work towards.
You know, you mentioned kind of what brings to mind a connected cockpit kind of realm, and there's a lot of these in cockpits these days. There's a lot of phone-based devices or apps and things that pilots are using for their navigation and such. Are you involved in that aspect of it as well? Obviously, that's a digital conversion.
Right. So if you look at any tablet, usually the radio, or the thing that talks on Wi-Fi, is ours or our other biggest competitors. There's really only 2 of us in that space. So we're heavily integrated in that. We're working with a partner right now about how we could actually take what right now is a Wi-Fi type connection, make some minor changes, and that becomes something that is far more acceptable to EASA and the FAA, for example, right? So, you know, can we work with RTCA so that you don't have to do an expensive modification? It's something small that allows that now to talk to the cockpit. You know, if you look at a lot of the communications that is done not in an airframe, there's not the requirement to guarantee packets and receipt of information like on a CAS system in a cockpit. So how do you work with industry partners and people like Apple and Samsung to start enabling that in what are now our electronic flight bags, right? Our electronic flight bag moved from the big JEP system down to an iPad. How do we get that same, basically, you know, you were looking at a DAL-D certified iPad, for example. That's how I simplify the explanation. And so we do a lot of that. We try to engage with RTCA, FAA certification. We do support some in China with COMAC, but not a lot. Trying to develop and get them comfortable with this as well, right?
You know, it's interesting that you talk about the certification piece of it, because I'm sure that you're involved in a lot of certification of devices that are using your products. Are your products often commercial off-the-shelf products, or are they purpose-built for the aviation industry and certified?
So there's actually a really interesting thing that happened in our industry, right? You have the automotive industry, which is really the standard for automotive, what they call functional safety, has come up so high that it's almost the same as you see in aviation, right? So interesting starting point there. We actually have COTS products as well, but we also have high performance products. So we have products that have to mitigate tin whiskering and a lot of things that both really the entire aerospace and defense industry is interested in. And so it's not just COTS, sometimes it's enhancing them. Sometimes, you know, if it's a passenger control panel, that probably doesn't have the certification requirements. So that can be easily COTS. When you start looking at a FADEC controller, now you're into what we call the high temperature portfolio, high reliability portfolio, enhanced products portfolio. So we do a lot of that. Something that's really exciting though is because we're a company that serves multiple markets, we have the ability to look at the automotive space and see what they're doing, use the volumes, right? Aviation is really challenged because we have very small volumes. And it's very hard to make the investment for new products. But Analog Devices has a really neat edge is that we take things from healthcare, downhole drilling, and especially automotive. We can pull those over. A lot of the work they do on their functional safety is very close to what the FAA or EASA would want to see, or actually the V-62 military guys want to start seeing. That, again, faster time to market, and now we can move that into basically the aviation space very quickly. So it's kind of an exciting new thing that we're seeing in the market, and it's being well accepted. Right now, the U.S. military is really encouraging these automotive qualified parts. And I would guess in a couple of years the FAA will move in step too.
Are you getting into the unmanned space as well?
We do a lot in unmanned. Primarily, most of our stuff is in the larger UAVs. A lot of military UAVs. We do support a lot of our products, especially our stuff that goes into ADAHRs. Our MEMS devices are in a lot of the smaller UAVs. Where we really shine there is the transceivers. So we have a lot of stuff that's very high power. As the spectrum becomes more congested and more difficult to send data across, we're very, very good at what's called blocker technology and things that allow the signal to get through. It's an advantage, and it kind of goes back to the transceiver cores and how the ADCs and the DACs work, is the faster you can do that, the more accuracy you can get. You can pull very good signal out of a lot of background noise. And so as UAVs propagate, we get more and more UAVs, how do you actually not step on each other, as we'd say in the, when we speak on the our aviation radios, we step on each other.
Sure.
That to a point happens in the data communication, the command and control links in big military UAVs, but also some of the civilian larger UAVs.
So are you looking at things like spectrum allocation and for instance, if you go to an NFL game and there's all this spectrum allocation that has to be done for all the communications headsets and all the, soon there will be drones flying at NFL games and those things. Is that the same kind of thing you're seeing as you come into, particularly with the propagation of drones in the airspace?
So we do. Our technology supports it. We don't define it though.
Okay.
Right? So, in our world, the FAA, the FTC, and everybody defines that for us.
Right.
If you look at some of the transceiver cores we have, they're accurate enough to do very complex military waveforms.
Right.
So backing into a UAV drone, it's not to sound arrogant, but it's actually really easy. And so
once you know the secret.
Yeah, once you back in. But it's going to continue to be a problem, right? Everybody remembers light speed with GPS, right? The challenge there was you couldn't split the spectrum, right? You couldn't pull your signal to noise ratio on a very grand scale was too great.
Right.
Technology is now advanced across the industry to be able to probably mitigate that if it happened today. It'd be much less of a concern.
You also talked a little bit about the kind of the back of the airplane. We all think about the front of the airplane because we're up there with all this stuff, but the folks in the back of the airplane who probably own it, that are on a tablet, they want to listen to music, they want to watch a movie, they want to be able to communicate with their business. That's all part of your range of products as well?
Yeah, so our portfolio, it's kind of new to us, and it's again, I don't always like to go back to it. If you look at the automotive Mercedes type stuff and what makes comfort for that kind of seat,
right?
It's actually an upgrade to what you're going to find in the back of most ATR aircraft. So we do that. We do a lot of things when it comes to control. A real big thing is how do you manage power across an airframe? Right? We're providing 120 volts, European might be 220 volts to each seat.
Right.
And so our power management portfolio does really well at that. How do you take the noise out of the lines, right? Electricity generates a lot of noise that can impact aircraft electronics. So with our new acquisition of Linear Technologies, it's a really good solution we can bring to the table. So, but again, we go through the big partners you see out on the floor in front of us who actually deliver it. We're the enabler technology.
Well, Sean, it's been great talking to you. I've learned a lot about things that I never really considered before with this conversation. So thanks very much for taking some time to talk with us, and best of luck, and I hope we'll see you around at shows in the future.
Oh, definitely, for sure. Well, thank you. I appreciate it.
Thanks very much.
Thank you.
Sean Darcy, who's the Director of Aerospace and Defense at Analog Devices.
Aero-News Network's coverage of the 61st Annual AEA International Convention and Trade Show, live from Las Vegas, is brought to you in part by the following sponsors.
Avidyne is the pilot-centric innovator. If you look at Avidyne's 20-plus year history, we had the first moving map, full color, that had everything on it. We were the first ones to do a primary flight display for general aviation. Avidyne has lots of opportunities and things in the works that will continue the leadership role we played in the past of coming up with new concepts and always having the best user interface to them.
Are you stall smart? Ever since Orville and Wilbur took to the skies, pilots have been taught that the more airspeed you have, the better off you are. But over the last 100 plus years, we've learned that's not always the case. Take stalls, for example. The common belief is that if you have sufficient airspeed, the aircraft won't stall. The fact is, an airfoil always stalls at the same critical angle of attack in relation to the relative airflow, regardless of airspeed, configuration, or weight. Learn more at aspenavionics.com.